Okay, I'd like to go over graphing of systems of equations. Solve the system by graphing. Solve the system means you got to find the answer for x and y. You make a little parentheses coordinate with a comma, x, y. Then there's two equations. Where the lines meet is the answer to the problem. So I go to a paper, and on one side I put y equals x plus 6. We have y equals x plus 6 and y equals x minus 2. Okay, y equals x plus 6 and y equals x minus 2. We put those two equations down, and then I go to scratch paper or notebook paper, whatever, and make a table. And on one side I line up y equals x plus 6, and on the other side y equals x minus 2. Now, in this equation, we need to graph it. Do you have the y and the x both in this equation? You do. Okay. Is y by itself? It is. So, we put m and b. You place a 1 in front of your x if to have an m. Okay. So, slope, y-intercept. That's what m and b mean, of course. So the slope is 1 over 1, and the y-intercept is plus 6. So on my y-axis, I go the y, 1, 2, 3, 4, 5, 6. And from there, I go up 1, forward 1. Okay, and then I take a straight edge or whatever and graph the equation. Okay. Okay, now the second one, y equals x minus 2, that has to be graphed. So y and x are both in the equation, and the y is by itself, so I got m and b. I just place a 1 in front of the x as a coefficient, if I needed something in front of x. So slope, y-intercept. So the slope is 1 over 1, and my y-intercept is minus 2. So on the y-axis, I go negative 1, negative 2. And from there, I go up 1, forward 1. Funny thing happens. The lines do not cross. They are parallel. That's called parallel. So we cross this out. We can't fill it out. And the answer is no solution when they're parallel. Because they're not going to cross. So this system has no solution. Okay, now in my next equation, our system, we have x minus y equals 5 in the first equation, and then in the second we have 3x plus y equals 3. So on one equation I have x minus y equals 5, and then in our second equation we have 3x plus y equals 3. Now this isn't going to be quite as easy, okay? Your x and y are both here. You make a 1. Well, y is not by itself. Well, that's kind of a problem. So what I do then is apply a multiplier of 1 to the y, make it plus negative, and I put a multiplication dot and circle it. Okay. Now, place a 1 in front of the x. Okay. You want both these, since the y is not by itself and you have to graph, you want both these to have multiplying numbers, and you apply 1s if they don't. Now, that is a negative. I do not want that negative, okay? So you have to apply the opposite rule to the equation, which is if I make this opposite, negative and positive now, and this is opposite, okay? Now I can go to the work of getting the y by itself. I take out the negative 1x by adding 1x, and then I make a 0x and add 1x there. Now we line up our equals and we drop the 1 times y term. Now I put x down, 0 plus 1 is 1, then plus negative 5. Then I divide everything by 1. Okay, that's going to be 1x. Remember, if it's a decimal, you leave it, and then plus negative 5. Now I have m and b. So the slope is 1 over 1, and the y-intercept is negative 5. Okay. So on the y-axis, I go down 1, 2, 3, 4, 5. And from that point, I go up 1, forward 1. Okay, and I can see how that's lining up. Okay, now let's get the second equation graphed. We have 3x plus y equals 3. Is y by itself? Yes, it is. So I would want y to have a coefficient so I can see what I have. I have a 1. Now that is positive. If it's positive, we're not going to do the opposite rule. We put a check mark and we go to town. So we take out the 3x by subtracting it. First got to do it to the other side, so I place a 0x and subtract 3x there. 0 minus 3 is negative 3, and then plus 3. Okay, now divide the whole system by the whole equation by 1. And when you divide something by 1, it just is the top number, so negative 3x plus 3. And now I have my m and my b. So the slope is negative 3 over 1, and the y-intercept is plus 3. So plus 3, 1, 2, 3. Then from there we go down 3, forward 1. And look what we found. We ran into the other line, so I take my ruler and I graph the points. Okay. Remember, you were lucky enough to run into your first line, but if you don't, you make the point yourself and circle it. Now you got to identify what point that is, the xy point. This is x, 0, 1, 2. You stop when you're right lined up with it. You're at 2 on x. Then on the y, that's the one going up and down, you have 0, and it's negative 1, negative 2, negative 3. Okay? So 2 is x, negative 3 is y. Now on x, right is positive, left is negative. You see that? Positive, negative. On y, up is positive, down is negative. Okay. So on the x line, you line up where you're at. And then on the y line, you line up where you're at. Okay, then the last one. Y equals 2x minus 1. And then negative 3x plus 3, negative 6x plus 3y equals negative 3. So again, I go make my table so I get the information I need to graph it. Y equals 2x minus 1. Then the other side you have negative 6x plus 3y equals negative 3. Now, the first equation's nice because we have y by itself. So I got m, b. Slope is 2. The y-intercept is minus 1. We want to put a 1 under that. Okay, so we go to negative 1 on the y, then up 2, forward 1. Okay, then negative 6x plus 3y equals negative 3. We have y and x, but now the y has to be isolated by itself. Now it's a times by 3. It is a positive 3, so I put a check. I don't have to apply the opposite rule. If that's a negative, you apply the opposite rule. Then I add 6x, and then I make a 0x and add 6x to that. So we have 3 times y on this side. Then I put x down, 0 and 6 is 6, plus negative 3. Now divide every value in the equation by 3. 6 divided by 3 is a whole number. It's 2, 2x. Negative 3 divided by 3 is also an integer, so negative 1. MB. So slope 2 over 1, y-int, negative 1. So on the y, I already got a point. Now I go up 2 over 1, Oh, you already got it. Oh, guess what? It's the same line. When it is the same line, it's called infinitely many solutions, otherwise known as IMS.